Today I'm going to demonstrate how to do polynomial division. So I have a cubic polynomial here, and I'm going to divide this linear term, x plus 1. Now, like most long division, we start with the highest order here, x, and we imagine how many times would I have to multiply x to give x cubed? And the answer is x squared. So I'll write that as the first part here, x squared. Then x squared times x is x cubed. X squared times 1 is plus x squared. So I multiply this by the entire factor and write the result down. I have to subtract all of that. So x cubed minus x cubed leaves nothing. It should always leave nothing at this point if it's working. Negative 7x squared minus another x squared is negative 8x squared. There are two terms in this factor, so I'll need two terms to work with. I'll bring down the negative 73x. And the cycle repeats. I think, what do I need to multiply by x to produce negative 8x squared? The answer is negative 8x. This multiplies by the entire factor. Negative 8x times x is negative 8x squared. Negative 8x times 1 is negative 8x. Subtract the entire, both terms. Negative 8x squared minus itself leaves nothing. Negative 73x. Be careful here. Subtracting negative 8 is the same as adding 8. So negative 73 plus 8 is negative 65x. Bring down the next term, negative 65. We repeat. What would need to multiply by x to produce negative 65x? The answer is negative 65. Multiply by both parts. Negative 65 by x is negative 65x. Negative 65 by 1 is negative 65. Subtract the entire, both terms. We are left with nothing. That means we're finished. That's good. That's what we wanted. We have divided the cubic by the linear term and been left with a quadratic result. Writing this more formally, I suppose as an equation, we would say x cubed minus 7x squared minus 73x minus 65 equals, well, it's the factor x plus 1 multiplied by the quadratic x squared minus 8x minus 65. We could continue and factorise this quadratic and then solve, but that's enough for now. The purpose of this quick video was to demonstrate long division of a polynomial by a linear factor to produce a lower order, so a second order polynomial instead of a third order polynomial.